Today we're going over the 1.2 test review. Unit 1.2 is all about proofs and logic. And proofs and logic involve us using proof properties, vocabulary words, and logical statements. So let's do all of that in this test review now. Looking at question number 1, we're going to fill in this proof using one of the words in the word bank. In order to do that, we should go over what each of the words in the word bank actually mean. The transitive property is the property that states if A equals B and B equals C, then we know that A equals C. In other words, you need 3 statements. Now, the symmetric property is basically the property where you see the same statement, but it's flipped around. For example, AB equals BA. The reflexive property is used if you see the same exact thing twice. For example, A equals A. And we use substitution whenever we are replacing one value with another. The keyword here is replace. So now that we know this, we can start to fill in our proof. Now in this proof, if I look at statements 2, 3, and 4 all together, we see some repeating terms. We see that angle TWV shows up twice, so I'm going to label that as A. RTS also shows up twice, and we're going to call this B. UTW also shows up twice, so we're going to refer to this as C. Now, if I read these statements all together, it says if A is congruent to B and B is congruent to C, then we can assume A is also congruent to C. This is a prime example of the transitive property. That's how we know the transitive property is the correct answer. Now that we've done this, let's move on to question number 2. In question number 2, we're using a word bank once again to fill in this proof. This time, we're looking for the reasons that explain statement number 3, and we're looking for a reason that explains statement number 5. So let's focus on statement number 3 for now. We want to know why angle 1 is congruent to angle 3 and why angle 2 is congruent to angle 4. To do this, we need help from the picture provided. If I locate angle 1 and I locate angle 3, these angles are positioned directly across from each other. That makes them vertical angles. This is what fills in the blank. Now we need to find statement number 5. If you look at statement number 5 and you compare it to statement number 2, they're virtually the same statement. The only difference is that angle 1 and 2 have been replaced with angle 3 and 4. We talked about this in the previous problem. Whenever we replace one thing with another, that is an example of the substitution property. So substitution goes in this blank. And now we are done with problem number 2. Let's move on to problem number 3. In problem number 3, once again, we're using the word bank to fill in this proof. It's a known fact that the first reason in any proof should always be the word given. So that's an easy one for us to do. Now, for the next step, this isn't necessarily in our word bank, but it's really helpful for us to fill in the last statement. We know that what we're trying to prove should always go last. So we're going to do this just to help us out in the future. All right, now we can go ahead and fill in reason number 2. We want to know why angle 8 is congruent to angle 6. In order for us to know that, we're going to look at the picture and locate those two angles. Angle 8 is up here, and angle 6 is down here. Looking at their position, these two are corresponding angles. So that fills in the blank. Now, for the next reason, we want to know why angle 8 and angle 7 are complementary. So we're going to go back to our diagram and we're going to locate angle 8 and angle 7. These two angles are right next to each other and they form a straight line. So we would call these types of angles a linear pair. And we know that all linear pairs are supplementary. Last but not least, we're going to fill in reason number 4. If I look at statement 3 and 4, they look very similar. The only difference is that angle 8 has been replaced with angle 6. This is an example of the substitution property. And that is how we fill in number 3. Let's move on to number 4. Question number 4 is the same thing. We're using a word bank to fill in this proof. We should know by now that reason number 1 will always be given. And in fact, if you look at the given statements, we actually have 2 different givens. Therefore, reason number 2 should also be the word given. Now, we're going to look at the diagram to fill in some of these other reasons. If I locate angle RPT and I locate angle GNM, these are corresponding angles. Now let's move on to reason number 4. I'm going to locate GNM and I'm going to locate WNV on our diagram. So G and M is here and WNV is directly across from it. These two are vertical angles, which fills in my reason. Now, for statement number 5, by the time we get here, we've had some terms that have already repeated in our proof. Basically, if we look at statement number 3, if RPT is congruent to GNM and GNM is congruent to WNV, then we can assume that angle RPT is congruent to angle WNV. This is true by the transitive property. Now let's fill in number 6. For number 6, we're going to look at the diagram and we're going to locate the two angles. We're going to locate PXG and we're going to locate GMN. These two are alternate interior angles. Now, just like we know the given goes first, we also know that the statement we're trying to prove has to go last. Therefore, our last blank should say angle GMN is congruent to angle WNV. And this is our completed proof. Now let's move on to talk about logical statements. There are a couple of different types of logical statements. However, for number 5, we want to know what the converse and the conditional of our original statement is. Now, they give us a statement as a biconditional, and we need to turn it into the conditional in the converse. Before we do that, we need to know what conditional and converse actually means. So let's assume that the first part of a sentence is called P. So in our sentence, 2 lines are perpendicular would be the first part of our sentence, P. And where it says they intersect at right angles, that is called Q. A conditional statement will say if P, then Q. And the converse will say if Q, then P. So our conditional needs to say if 2 lines are perpendicular, then they intersect at right angles. Knowing this information, we can eliminate some answer choices. We know that the first one is incorrect because it doesn't start with 2 lines are perpendicular. We also know that C is incorrect for the same reason. Now we need to identify the converse. The converse would say if lines intersect at right angles, then they are perpendicular. There's only one option that says this, and that is answer choice D, which is the correct answer. Now that we know this, let's do number 6. For number 6, we want to know the converse, inverse, and contrapositive of this statement. It's very important to note that the inverse says if not P, then not Q. Now, the converse doesn't just add the word not. It actually negates or does the opposite of the original statement. Our statement already has the word not in it. So the inverse would actually remove the word not from our statement. So if you look at that, answer choice C would be incorrect because it still has the word not in it. And we could cancel out choice B because it's not in the correct order. So our choices right now are A and D, but we need to check on the converse and the contrapositive. Remember, we said earlier that the converse should flip our statement around. It should say, if Q, then P. So our converse should just say, if the corresponding angles are not congruent, then the two triangles are not similar. The only answer choice that says that is answer choice D once again. And that is it for the 1.2 test review.